All right, if you've watched the other 5, then you finally made it to section 6, projectile motion functions. So this is just like the do now we did in class. A little bit involved, but using quadratic formula on each problem here, well, except for the last one, is a pretty simple way as long as you get the equation and then you follow all of your numbers. So hopefully you've tried this one on your own already. There's definitely a question like this on the test, so you want to make sure you know this. This is your open-ended. So here we go. Roscoe hit a ball straight up at a speed of 96 feet per second. His bat hit the ball at a height of 3 feet above the ground. Give all answers in hundredths. So, starting out here, we first, even though A doesn't ask us to write an equation, if we're going to find out how many seconds the ball hits the ground, when does it pass the point it was hit, what's the maximum height, all that stuff, we definitely need to have an equation. So, remember our projectile motion equation is y equals a times x squared plus your initial velocity times x plus your initial height. Remember, a is either negative 4.9 if it's meters, if the problem's in meters, or it's negative 16 if the problem is in feet. Since this says 96 feet per second, the problem's in feet, so A is automatically negative 16. So the equation that you need for this problem, so all I'm putting on this page here, is y equals negative 16 x squared. The initial velocity said 96 feet per second. That's the speed it was hit at, so plus 96x. And the initial height was said 3 feet above the ground, so plus 3. So you can't go anywhere, do anything without this equation. You have to have that first, even though the problem doesn't ask for it. That's what we're going to keep going back to. Okay, so now that we have that, we can get started on A. After how many seconds did the ball hit the ground? Well, if something is hitting the ground, then we know that the height of that object is equal to 0. In our equation, height is represented by y, so in this case, y equals 0. And we know how to solve those equations. We did that back in section 2. So for A, our equation is 0 equals negative 16x squared plus 96x plus 3. Now I could try to go ahead and factor this. Both numbers this big, I'm automatically kind of guessing it's not going to be factorable, because especially real-world type problems usually aren't, because numbers aren't that nice to us in the real world. Just like going shopping, nothing can ever be just $10. It's got to be $9.99. Okay, so we might as well automatically jump in and use the formula that works every single time, whether it can be factored or not, and that is the quadratic formula. So, to do the quadratic formula, first 3 things you need to know, A, B, and C. A is negative 16, B is 96, C is 3. And we plug into the formula. I'm not going to write out the formula again. I'm just going to go ahead and plug it. So, x equals the opposite of b. So, negative 96 plus or minus the square root of b squared. So, 96 squared minus 4 times a, which is negative 16, times c, which is 3. Dividing that by 2 times negative 16. So these numbers are going to get a bit big, so I'm definitely going to have to go to a second page. So if you need to, flip back and forth as necessary. So I got x equals, when I simplify everything under the square root, 96 squared minus 4 times negative 16 times 3. I get negative 96 plus or minus the square root of 9408. And that is divided by negative 32, because 2 times negative 16 is negative 32. So, since I did all that in one nice step in my notes, maybe I don't have to go onto a second page. So here's where we split. We got one where we're adding, so negative 96 plus the square root of 9408 divided by negative 32. And over here I have negative 96 minus the square root of 9408 divided by negative 32. Okay, so when I solve this, I hate how messy this gets. When I solve this top one here, this equals negative 0.03. And this one on the bottom here, this one equals 6.03. Okay, so now let's remember we're talking about the time the ball hit the ground. Well, the ball can't hit the ground if I haven't hit the ball yet. And when I hit the ball, it's time 0. So this answer here is not possible. First of all, I can't have negative time. I can't go back in time no matter how much we want to sometimes. So I can't have negative time. So my only answer to this problem, since it's a real-world question asking us to solve a real-world problem, the ball hits the ground after 6.03 seconds. So I'm going to erase some of this stuff here because a real-world question needs a sentence as an answer. So the ball will hit the ground after 6.03 seconds. And there's a solution for A. Okay? For B, it asks, when does the ball pass the point from which it was hit? So again, it's asking something about height. So on to B. The ball was hit. When does it pass the point it was hit from? Well, where was the ball hit from? 3 feet above the ground. So pass the point it was hit, that height that it was hit at was 3 feet. Remember, height is y, which means y equals 3. So my new equation that I have in B is 3 equals that equation that we had, negative 16x squared plus 96x plus 3. Now you remember our rule when we're solving an equation, is it allowed to equal 3 or any other number? No, it has to equal, what is it? 0. So this 3 is not allowed to be a 3, it has to be a 0, so I have to make it 0 by subtracting the 3. I subtract the 3 on this side also, and I end up with negative 16x squared plus 96x plus 0. My constants actually cancel out. Now I can use a quadratic formula to solve this quadratic equation. So let me just erase some of these notes here. I'll rewrite this equation. 0 equals negative 16x squared plus 96x plus 0. Of course, that 0 on the end you don't really need, but it's a nice placeholder to remind yourself that that's what C is. So A is negative 16, B is 96, and C is 0, whereas in the last problem C was 3. So now I use quadratic formula, opposite of B, so negative 96 plus or minus the square root of B squared, so 96 squared minus 4 times A, which is 16, times C, which is now 0, divided by 2 times negative 16. So because C is 0, this whole piece is going to cancel out because anything times 0 is 0. So this is now x equals negative 96 plus or minus the square root of 96 squared divided by 2 times negative 16, which is negative 32. So now, again, if you remember, and you could do the math, 96 squared and then the square root of that, but remember, square root and squared undo each other. So this is really saying x equals negative 96 plus or minus 96 divided by negative 32. And we can set up our two equations from here. So, one equation is going to be negative 96 plus 96 divided by negative 32. The other, negative 96 minus 96 divided by negative 32. Well, the negative 96 plus 96, those guys cancel and leave you with 0 divided by negative 32, which is just 0, which makes sense because the ball was hit at the 3-foot mark. So at 0 seconds, the ball was at 3 feet because that's where it was hit from. The bottom, negative 96 minus 96, divided by negative 32, this is exactly 6. So what happens is, let me just draw you a lovely little picture for you, if you're trying to figure out how to picture this in your head, right? I'm standing at home plate with a bat in my hand. The ball is pitched in. You swing the bat. At 0 seconds, before anything else happens, the ball is hit up into the air. Okay, so that's at 0 seconds. The ball is hit up into the air. Whoa. I did not mean to do that. Go away. Oh, what is that? Oh, now I just made a royal mess of my drawing. Where's undo? Undo? No, not undo. Okay, hold on. Sorry. Let me back up. Put a bunch of math on my pretty drawing here. Okay, so let's try that again. So I take the bat, I hit the ball, swing the bat, hit the ball from here at 0 seconds. The bat hits the ball goes up into the air. This is 3 feet above the ground. The ball goes up into the air. When it passes that mark again, that 3-foot mark from which I hit it, how many seconds later is that? This problem is saying it's 6 seconds later. And it's passing the 3-foot mark again. We found out in A when it hit the ground. And that was at 6.03 seconds, which pretty much makes sense because 3 feet is not that far off the ground. So it only takes an extra couple hundredths of a second to hit the ground. So, needless to say, after my beautiful drawing and my even more beautiful math that I did, the final answer to this problem is that after 6 seconds, the ball passes the point from which it was hit. All right, and there's your real-world answer for B. Okay, on to C. So C asks, what is the maximum height reached by the ball? When does it reach this height? If you remember, I said if it ever asks for maximum or minimum, that's code word for, who remembers, vertex. They're asking you to find the vertex. So the maximum height reached by the ball, and when does it reach this height? Find the vertex. So to find the vertex, we first have to start with the x-coordinate because we have an equation for that. So x-coordinate of vertex, remember, is found by taking the opposite of b and dividing it by 2 times a. So, back to our original equation that we had, negative 16x squared plus 96x plus 3. So I'm going to take that original equation and take the a and the b from it to find the x-coordinate of the vertex. So this is negative 96 divided by 2 times negative 16. So the x-coordinate of the vertex is equal to, where is it in my notes? 3. Okay, so that's x-coordinate of vertex. How do we find y-coordinate? Well, hopefully you remember this as well. Y-coordinate of vertex, plug in x, right? So if x equals 3, what does y equal? Well, y would equal negative 16 times 3 squared plus 96 times 3 plus 3. And when we solve that out, we get 147. So the vertex is 3, 147. So now I'm going to erase all that work that I did to get there. You, of course, if you need to, go back or pause. Okay, so vertex is 3, 147. Again, this is a real world question that deserves a real world answer, not just saying, oh, maximum 3, 147. That's not going to answer anybody's question. So we then write the ball reached a maximum height of 147 feet after 3 seconds. All right, so remember, x is your time, so this is your seconds, and y is your height, so this is your feet. And then that's why the vertex helps us find the maximum. After 3 seconds, the ball reaches a maximum height of 147 feet, or the ball reached a maximum height of 147 feet after 3 seconds. And that, my students, is the end of the 7.0, 7.4 test review. It's a lot of stuff. It's not obviously going to be that long on the test, but practice, practice, practice. If you need more practice problems, Google or go back through our notes and our other practice worksheets. And good luck on your test. I'll see you in class.